All right, this is the kind of a differential equation associated with this energy minimization problem. We're going to be reviewing this kind of a derivation later on, right? So basically, what we have linked is we have shown a first example of linking a differential equation with a energy minimization problem. And it turns out this is just one example of the many differential equations that can be formulated into a energy minimization problem. And finite element is really suitable for solving this kind of equations that is formulated into a energy minimization problem. All right. Okay. So we still have about 10 minutes, and let's just go through a finite element example of solving this very particular problem when you write it into an energy minimization problem. So minimizing what you can see as a linear form that's basically have u here, and a quadratic form that has the square of a derivative in it. All right. So for example, I'm going to be minimizing integration from 0 to 1. My rho gu plus at times du dx squared. Okay, so in this case, let's actually use a little bit more elements. So in previous example, we used 2 elements. In this example, let's actually use 3 elements. Let's go from 0, 1, let's do a third and 2/3. Okay, so we have 3 elements here, here, and here. And my function u, well, let's actually put the 0 line to be here. So 0 here, this is my x, right? Have a third and 2/3. My u is going to be a linear function here, another linear function here, and a linear function here. We have restricted u to be 0 at 0 and 1. So what we have is, let's actually denote this as u1 and u2, the values of u at 1/3 and 2/3. How about that? All right. Once we have this setup, we have restricted the solution u into basically a very restrictive set of functions. Okay, that can be parameterized with just 2 degrees of freedom. The value of the function in the first element can be simply written as u of x in the first element is equal to what? Is equal to u1 times 3x, right? Because yeah, when x is equal to 1/3, the value of the function is equal to u1. When x is equal to 0, it's equal to 0. So in the first elements. In the second element, my u of x is going to be a little bit different. It's going to be u2 minus u1. So that's this the delta here, right? That can be multiplied with 3x minus 1, and then plus u1. So this is constructed such that when x is equal to 1/3, this is going to be 0, and we are left with u1. But when x is equal to 2/3, this is evaluated to 1, right? So that u2 minus u1 plus u1 is equal to u2. So we match here and here. All right. And finally, in the third element, we have ux is equal to u3 minus u2, 2x minus 2 plus u2. right? And if we have more elements, we can just keep going on like that, right? So this is the values of the function on these three different elements.